Welcome to Chemistry Wide. Today we will see going to projection formula and relative configuration in stereochemistry. See, what is the configuration? Please see the definition first. The three-dimensional arrangement of atom or groups in a molecule is called configuration. Or how to look three arrangement of molecule configuration at space. First one relative configuration, second one absolute configuration. Projection formula. See, projection. What is the projection? Means the three-dimensional molecule represents to the two-dimensional molecules at a paper, board or system. It is called projection. Three types of projection formula. First one Fisher projection, second one Newman projection, third one Source projection. Newman projection, there is only one N. Sorry, I written mistakenly. First we will see Fisher projection. For example, glucose molecule. See the glucose. This is the glucose structural formula. CHO, CHOH, 4 times CH2OH. This is the general formula for glucose, but at Fisher projection we can write at a vertical position. Sorry. This is the aldehyde group. Aldehyde. This is the alcohol. This is also alcohol. This is primary alcohol. See below. At terminal carbon means top and bottom, not between. So at a terminal carbon, one is aldehyde. This is aldehyde. Another one is primary alcohol. This is primary alcohol, which is easily oxidizable above the two functional group. Which is very easily oxidizable above the two functional group. Here aldehyde is easily oxidizable, so it is going to top. Automatically next terminal carbon is going to down or bottom. So give the first priority for the aldehyde group. We can write like this: CHO, C, 4 times carbon, and last one CH2OH, primary alcohol. I think we know that primary alcohol, secondary alcohol, tertiary alcohol, quaternary alcohol. This is the primary alcohol, CH2 and OH. Here if we take lactic acid, see the lactic acid, COOH, HOH, CH3. This is the first, give the first priority for carboxylic acid, COOH group. Next methyl group is B. C is the hydrogen, alcohol is the D. At Fisher projection, see careful, At pressure projection, carboxylic acid going to top, methyl groups going to bottom. Left side one is hydrogen, right side is the alcohol. So here view, observer view, A is the carboxylic acid, B is the methyl group, C is the hydrogen, D is the alcohol. At a pressure projection means we already seen at a two-dimensional, three-dimensional arrangement of group or atom we can see look at the two-dimensional. It is called projection. So if you don't understand, please pause the video and see. Here see, here going to see, this is going to D, A is top, B is the bottom at a pressure projection. SARS projection, for example ethane molecule. Ethane, we know that CH3 2 methyl group. This is the one carbon, this circle is another carbon, just like that. This is the one carbon, this circle is another carbon, this circle is another carbon is hidden. See here, circle carbon is hidden. This form is eclipsed form. Eclipsed means in Tamil, how to tell in Tamil? மறைத்தல், மறைந்து இருத்தல். We can rotate at 120 degree this molecule, it is going to staggered form. This both methyl group is not hidden. See, there is hidden, there is no hidden. At a pressure projection using for conformational analysis and elimination reaction. Next one, Neumann projection. For example, butane. Here substitute between the two methyl group. This is the methyl group, this is the methyl group. These both are substituent. See, butane. This circle is, this is the first carbon, circle is the first carbon. This is the second carbon, place in the vertical line is second carbon, this circle is the first carbon. This H, eclipsed conformation or eclipsed form. Here first methyl group is represented proximal. Proximal means front. First methyl group, and the second methyl group is represented distal or circle back. See, if you rotate at 60 degree, this eclipse forms going to this form. Again we can rotate 60 degree, this CH3 methyl groups going to bottom. Again if we rotate 60 degree. See here both methyl groups is opposite side. Here 1 and 4 exactly opposite side, opposite position. It is called gauge form or anti-conformation. After Fisher projection, source projection, Newman projection used for the three-dimensional molecule represents as two-dimensional molecule. Say two-dimensional molecules. Configuration. What is the configuration? Relative configuration. Second one, absolute configuration. First we will say relative configuration. Say if we taken glyceraldehyde is as the standard molecule to express the configuration of an organic molecule is terms of relative configuration. Here glyceraldehyde is a standard molecule. See the below the structure CH2OH, CH2OH, CH2OH. This is a glycerol. Glyceraldehyde is means it is aldehyde functional group. So when oxidize this glycerol, the primary CH2OH is going to CHO. The primary CH2OH going to CHO. See below. This carbon is terminal. This also terminal carbon. This point, center point of the carbon is asymmetric or chiral carbon. Okay, it is optically active. So we can first priority for alcohol because O oxygen here, oxygen atomic number is 8. Then other compound. So first given high priority for OH group. So we can atomic number. This is the first priority. Right side, this OH alcohol group is right side. Right side D glyceraldehyde. This alcohol group is going to left side. This is first priority. OH always first priority because oxygen atomic number is 8. Then other element like hydrogen and carbon. Okay, this is the first priority. So left side, this CH is terminal, here CH2 is terminal. Cl glyceraldehyde. This carbon is asymmetric or chiral. Here OH group on C2 is on the right side. C2 means this carbon is C2, second carbon. This is second carbon, this is the first carbon, this is third carbon. Here OH group on Ca2 is on the left side. OH is at the left side for carbon 2. Below, if compound contains more chiral carbons, say more than one chiral center in the compound. If the more electronegative group is on the right side of the highest number the chiral carbon, it is designated D. See below example. This is not negative charge, it is denoted by another attached group, any group like alkyl group, like this. Here this is the terminal carbon. This structure is D-glucose. OH is first. This is the L-arabinose, left OH, left OH. This OH going to left. There is no terminal carbon, so we given OH for this one. Here two terminal carbon is found, so this OH going to left side, and this third structure L-TRIOS, because this is the terminal carbon, this is also terminal carbon. Here left OH is right side, here OH is left side, here OH is left side. Here chiral or asymmetric carbon, this is chiral or asymmetric carbon. Here two chiral or asymmetric carbon. Okay, are you understand? There is only one terminal carbon, so we given like this. Here two terminal carbon and one substituent. Here both are terminal carbon, it is called TRIOS. So this is also chiral and this is also chiral, asymmetric carbon, asymmetric carbon. Note here, if more chiral compound comes out to identify, here we can tell only one chiral carbon atom in this projection, but we can't tell more chiral carbon. It is very drawback, it is a big drawback DL system of given the configuration. Okay, next. Please subscribe the channel, more videos on the way. Thanking you all.